And then finishing up with this section. Similarly, we could find the derivative inverse secant, but we've already done that twice. So we'll just cut to the chase that the derivative of inverse secant is 1 over the absolute value of the square root of u squared minus 1 du dx. And cosecant inverse, same thing, with just a negative. Notice all the co-functions have the same derivatives, they're just negatives. You aren't memorizing 6 different formulas, you're memorizing 3 formulas. Now, if you forget the absolute value around it, I'm not going to be particularly concerned. That's all about mathematical precision and the weird intervals that u is defined on and whatnot. Don't worry about that. I won't take off for the missing absolute value. The computer might, so you just need to be careful with the computer. So we just want to use these things. So again, similar to what we did before, first of all, the logarithm. Let's do the logarithm first. And so that's 1 over the argument, derivative of the argument. One over argument, derivative argument. And now we're going to use that the derivative of secant inverse of u is 1 over the absolute value of u, square root of u squared minus 1 du dx, with in this case u being 5x. So 1 over secant inverse of 5x, then 1 over absolute value of u, but u is 5x. So the absolute value of 5x, the square root of 5x squared minus 1, then du dx times 5. So there's the u squared, du dx. Just plugging into that formula. And now making it look pretty. And you can just trust me on this. That 5 and the absolute value 5 are going to cancel. And so I've got 1 over, excuse me, secant inverse of 5x, then the square root of 25x squared minus 1. And there's my derivative. And there's nothing else you can do, although someone out there is going to move that secant in the numerator. They're going to say, oh, that's secant to the negative 1. But it's not secant to the negative 1. It's inverse secant. And so you cannot treat that as an exponent because it's not an exponent. Okay, our last problem in this section. So when we get to the cosecant inverse of 3x, we will eventually use that the derivative of cosecant inverse of u is negative 1 over the absolute value of u squared minus 1 du dx, with, in this case, u equal e to the 3x. But that's not where we're going to get to first. Just going to do a little rewriting here. And as we've done these more and more complicated derivatives, sometimes when we throw in something simple, people are like, what do you do with this? This guy, just a basic chain rule here. Here, a product. So here, chain, here, product rule. So starting with my chain rule, multiply by that exponent, decrease the exponent by 1, chain rule, times derivative of the inside, 2x. Then minus, in a big set of parentheses, product rule. Plane first, derivative of the second. So now it's time for the cosecant inverse. Now it's time for my formula. So negative 1 over the absolute value of e to the 3x, square root of e to the 3x squared minus 1, then du dx, e to the 3x times 3. There's u squared, du dx. And remember my words here. There's my du dx. repeats, natural log repeats, derivative of the exponent. So there's the first half of the product rule. I'm running out of room. So we'll drop down and do the second half of the product rule. So it was plane first, derivative of the second, plane second, derivative of the first. So plane first, derivative second, plane second, derivative first. Okay, let's clean that bad boy up. I'm not going to accept that as an answer. Okay, so I'm just going to try to get it all on one line and getting rid of all the red, which I'm not sure that the red helps or whatnot. I'm trying to get it all on one line. First of all, I do notice here the 1/2 and the 2 cancel. So I'm going to have x over the square root of x squared minus 1 on that first term. And then distributing that minus sign, and so a negative times a negative right here is going to be positive. And so what I have in the numerator here is 3x e to the 3x over the absolute value of e to the 3x, the square root of e to the 6x minus 1. So that's all this guy right here. The two negatives, we're going to make it positive. Then I had the 3, the x, and the e to the 3x all in the numerator. And the denominator, the absolute value, and then exponents to exponents I multiply. So that's everything in this first term. The two negatives made it positive. And then I had a 3, so there's the 3. I had an x, there's the x. I had an e to the 3x, there's the e to the 3x. In the denominator, had the absolute value. Then the radical and exponents to exponents multiply. Distributing that minus sign, so then it's going to be minus cosecant inverse e to the 3x. Then e to the 3x is always positive, so those guys cancel. And so pretty answer, x over the square root of x squared minus 1 plus 3x over the square root of e to the 6x minus 1 minus cosecant inverse e to the 3x. And we have differentiated that. And that concludes the end of this section.